Ah, there we are. Hello again. Welcome back to another stream, another week here at the agency. We're building a text adventure game engine, or an interactive fiction engine, if you will. Not all text, not all things. We have a cool GUI for it and everything. And eventually we're going to add graphics and sound and some authoring tools to help us build out kind of the content for the game and that kind of stuff. So as my Twitch settings here. So yeah, let's get down to business today. Let's see. Let's bring up the to-do list here. We got a few things to work on. I think we got to still get save loading to go, if I'm not mistaken. Restoring saves. So let's start building the project. So it's always ready to go when we're ready to go. Let's see, projects, engine, booyah. Okay. This is what it looks like. Let's just run it. All right, so far, pretty basic. I'll admit it, it's cool. We got save files working last week, I believe. So we have the ability to say, pick up this shovel. All right, we can walk into the front door. We can then save foo1. There. So save the game, and now what we need to be able to do is load foo1 and get that going. So that we could quit, and start up the game, and load it. I had some a few more ideas for the game too as well, which maybe we'll discuss if we have some time about that this week, and start working on that part of the adventure engine again. Kind of give us a showcase game to work with. And yeah, and then if you want to, hopefully that'll be like done-ish, version 1.0. And if you want to make your own adventure games with it, download it, we'll cut a release and everything. That'll be great. But for now, first things first, we need users to be able to load their saved games. That one should be done, I believe. Yeah. So adding a restore/load command. I'm going to call it load because historical computer reasons. Right. So we got our code here. We're going to load up source, adventure, engine. Here's our special commands down at the bottom. Save game state, load game state, and all that. We just have to hook up the load game state function to the front end to get things going there. Let's get some. So we go to GUI. So we have some front end code that handles the I/O of the loading and saving things, because the main thread here is run by the GUI. So let us then have a do game load. That'll do something. When it does do game load though, game state I should return. Something like that. I'm going to leave it undefined for now. Let's see. Handle event. Yeah, so we have the app game saved things. We have to do this with signals. Or something like that with Monomer there. Yeah, tasks. That's what it is. All right, so we're going to fire off a task to get our game loaded. And then we'll update the game model, the game state, to be the loaded game state from the save file. So I'm going to call this load game. The name. Now, I'm not sure how we're going to update the game model state from this task action yet. We might need some examples of how to do that. Although, no, maybe we'll be fine, because app game, yeah, we'll be fine. App game saved, it gets called with the result of this action, so this will have a new game state. We can update it there. So that's no problem. Load game, we'll just fire off this task. App game loaded. View game load, fname. And then supposedly we will have a type here for app game loaded, which will take our new game state, a loaded game state, and we will return merely a model with the loaded game state. Now that's going to probably fire up a whole bunch of missing stuff because we don't have types for these things, constructors, so we should probably handle those. App events, app game loaded, a game state, and let's see, we have, what else are we missing? Load game, right? Yeah. So load game is part of our user command type, which I believe comes from engine. Yes. Load game, file path, we'll add that there. Maybe right there is fine. Right after say game, load game. It's a pair. They should be close together. Now, when we handle the command, or handle the input, we have to check for our special case and emit that user command result. So we have load, and then fname should be the next argument. And if that's true, then we'll have load game. Just like save game. And there we go. Okay. Code's green. We're compiling. We're good. What's next? So that's all hooked up. We just have to actually implement do game load. Yeah. Okay. So remember, we have to remember that when we do these tasks from Monomer's main thread, if there is some IO exception, like the file doesn't exist or something like that, Monomer's not going to know, be able to tell the user about it or know about it, right? It's going to ignore everything that comes out of IO. It's just going to be like, that's up to you, programmer, to handle. So we're going to have to do some work here, perhaps, to make sure that we can emit those errors back in. Sort of like we do with do game saves. We might need to add some types for like file not found or save file not found or whatever. That sort of thing. Let's take our argument, fname, and do some stuff with it. The home dr root, so on and so forth. Get the home directory. The same game path. Very similar code. Like that. Dot adventure engine saves and fname. Now, instead of writing the file, we're going to read it. So we need our results is going to be the run except T, save game state, load game state. Our save game path. I think that's all we need. Hopefully. Something. Something like that. Something roughly like that. Right. Okay, we should just have whole errors as our type errors. Yeah, IO game state. IO game state. Mistyped except T. Thank you, GHC, for reminding me. Okay. Super. One hole, two holes. Too many arguments to load game state. How did I implement that? Let's go back over the engine here. Load game state. File path. Returns a game state. Takes one file path, one argument. Ah, yes. I forgot to add a simple apply operator. There. IO game state, IO game state. Okay, there's our two holes. That's fine and good. So in the left case, we need to do something here as well. I'm going to add the same to-do note for debug logging. We could actually reuse file not saved. File not loaded. We might need a new error case here. Failed to load. Heat up hack fname. And then we should only have one hole, except and a type error for file not loaded. That's our save file results. We might need one for a load file result. We have file not loaded, so we're going to do load file result as our return type actually for do game load. Load file result. And the success case will be file loaded and with the game state. So we know what to do with that here. Right, if we have the game state, then we can just write with our pure file loaded game state. Now this should be updated in the GUI where we're pattern matching on that. Up here when we handle the app game loaded game state. So we have results, and we need a pattern match on here. Yeah, I'll yank that up, so we'll need that. Results of... No, we'll go a message, just like above. We'll just unwrap the message into it. File loaded and game state. We'll just have a generic success message. Like, loaded And maybe we should have the file name in there as well. So I'll put the F name and the game state. We'll ignore that here because we just wanted to get the text message to display to the user when we actually load that game state. Yeah. Super. Okay. That's our message. Let's put it in something. Well, the only case where we're actually going to return well, actually we have, let's see, model. We're going to return the old model in the failure case. And we're going to return the loaded model, the new game state that we loaded from the file, plus our updated message loaded into it to display to the user to say that it was successful and let them know. So let's see, how should we structure that? I almost want to case match on the result itself here and just have like have this as a function to get the message. So I'll pull that for a second. Let's try it this way. File not loaded. No, hang on. File not loaded. Yeah, let's try that out. Case results. If we get some duplication, we'll fix it later. Case result of file not loaded. Message. All right. Return model with the model we have currently, where game errors is set to message const onto the model of the current game errors. And in the file loaded case, the success case, let's get the, actually, no, game state should be fine. Yeah, game state. Let's return a model game state where, and we'll just, game errors can be set to exactly just our loaded message. And, oh, this is where we want the file name that was passed in. As part of the success message, but just so we can display it there. But yeah, that should be about right. So file loaded, text, let's just convert it to text here for simplicity's case. So file loaded, and we can put fname here. All right. And that's load file results. Wait. Mismatch error, type mismatch error here. In the pattern, file loaded, Name game state. 108. Could match expected type game state with load file results. File loaded fname game state. Oh, right. App game loaded. Yes, app game loaded needs to be updated here. That's what that is. Load file results. Bang. Okay, linking looks like a good sign. And we're green again. Right. Okay, so when we loaded that should... Let's see, that's looking pretty okay. Let's give it a shot, see what happens here. So we look at our directory of save files. We have foo test 123, foo.9, foo1. Few of them. Hey, Swarm Collective. Nice to see you again. I am doing well. I am on vacation this week. I'm having a good time just hanging out and doing whatevers. And streaming. Streaming tonight. Glad to see you too. Thanks for stopping in on the stream. Yes, vacay. You gotta use it, right? You don't use it, it's gone. So take them often as you can. Yeah. So let's try it out. Ah, so many bangs, bong. There we go. Okay. So if all goes well, I should be able to load something funky with my input here. That's working. Load, there we go. Foo1. Loaded Foo1. We are back to our game state we were at when we saved the file. So let's drop the shovel here. So we drop the shovel in the main hall. We're no longer holding anything. Let's save Foo1 again, overwriting it. Let's quit. Fire up the game again. We've come back a few hours later to pick up where we were. And boom, here we are. Shovels on the floor, nothing in our inventory. These are all the scenes we've seen so far in the game. Cool. So we got save file loading and saving and loading and all that stuff. Nothing too fancy here, of course. So, I mean, this is what our save file looks like. Let's just take a little poke in one. All right, it's one giant blob of the whole thing. Now, the only thing that's with this is that if the user really wanted to, because we're serializing out the whole game state, including the world, right, they could dig into here and figure out how to beat the game. It's not terribly fancy in that respect. All right, so there might be a better way of handling save files for this. Could encrypt it. I don't know. I don't know how I want to do it. Like, personally, as a developer, I'm like, hey, this would be kind of cool. If I wanted to, I could just hack my own save game file and mess around with it. Another thing we could do is we could have like the world database itself. When you create a distribution of the game, could compile that into the binary that gets run on the user's computer. And that way, at least the save state only has to save like pointers to things. Yeah, and if they mod the game, they might lose the fun of the game, but that's their own prerogative, I think. I'm all user freedom kind of in that respect. People go to great lengths to save hack and mod hack all kinds of games and ROMs and stuff. Why make it more difficult? I don't know, right? So I think this is okay for now. The only other modification I want to make to the save files is just to make sure that when we the developer, change the game engine and change the definitions and the types, that we can still load old save files and upgrade them to newer ones. All right, so if you mod your save file, you might break your game, you might mess around with it and make it more fun for yourself. Might just be neat for you to poke around in there and do what you can with it. Yeah, save game loading is pretty challenging for some game engines. As a user, it always frustrates the hell out of me when I lose a save game that I've been working on for a long time, and the developer releases a new version and it just doesn't work anymore. And it's like, okay, well, I guess I got to downgrade my game and finish this, I guess. So I know each game's different and everyone has their reasons on it for it, but I'm hoping that we can do something about it here. So that's that. Let's go to our to-do file. Here, added the load command. So that's for save file versioning. To that end, there is potentially a way to do it. We don't have to go too deep into it, but there's a library I wrote a long time ago called Data Version. This library lets you do basically that. And I created it because I was working on a database at the time, a document data store, and it had an untyped schema that was not checked by anything. It was just a bunch of JSON that had changed over the years by different developers and different releases of the software, writing data and storing it onto a disk somewhere and then forgetting about it, until a user happily one day tries to load it back up again. And the software's changed, so it can't read that data anymore. Oops. Unfortunately, couldn't happen at the time. Users who were, this was an enterprise system, so users who stored data in that database wanted it out again, and it was their data, so I wrote a system that would read those JSON objects into, or untyped JSON documents into a really big, massive type. And then I would slowly pick out pieces of it into smaller bits, records that I could version at the type level. And so what this library lets you do is it gives you this instance, this transform instance that lets you kind of migrate between versions of your records from old ones to new ones on the fly using generics. So you give the functions that tell it how to update from version 0 to version 1. For example, by giving it an instance for foo version 0. So this tells us how to go up one version. And it figures out the difference between the two records. The API isn't terribly great right now. I haven't worked on it in a long time. I really need to fix that. But it gives you the ability to go between two records, and it'll figure out by diffing the two, reflecting the two records and finding out what's the difference between them. And then it'll ask you to fill in the holes. So if it changed type, if you need to provide a value, or if you change the name of something and all those things, it can figure those things out. So in this example here, the difference is that we have a foo ID int and a foo name string. Then we added a foo honorific, and we changed the type of foo name to myString. So we decided to go from like from a looser type to a stronger type. We added a new field. And so it can figure that out. And we have to give it a function that gives it a value for honorific. So we have to give it a default one because we don't know what it should be, starting from foo 0. And we have to give a transformation from string to myString. So we give the constructor for myString. And so we have a foo v0 record. We want to get a foo1, we can just call up on the v0 one. And it just applies the transformations to upgrade it. And so the type system basically doesn't let you cheat and forget fields or forget to add stuff or forget to provide a function to change the types and all those sorts of things that you normally get in these kind of migration type jobs. So maybe we'll use this library and maybe improve the API, because ultimately I want to provide a nicer experience than this. Because it doesn't tell you. I'd like to be able to put the record fields there. Yeah, very, very terse. And so my ideal API here would be for you to give the programmer to give the labels of the fields that these apply to. All right, so this const esquire here, would be nice to have like a little like hash foo honorific and then equals this. And then that would say, okay, cool. So that as you're reading the code, you can tell which field this applies to. All right, that's kind of the next step for that library. But once that's done, I think that's pretty much it, and then just keeping it from bit rotting. But this is that's a pretty tricky library to work on because it's all type level stuff. And it's like stuff like I'm okay at, but I'm not super great at. So it's pretty dense, as you can see. Some type level astronaut stuff. But it has a practical use, so that's how I justify it. Interesting idea, Swarm Collective. So adding if logic to provide different values based on other fields. Cool, yeah, follow away. If you can figure that out, that would be awesome. Maybe if we just pass in the old v0 record into those functions where we have to provide a default value, those kinds of new field functions, which you can figure out on the type level, which ones those are. You can pass in a copy of the record. I think actually that might be how it works, if I'm not mistaken, because that makes the most sense. It's internal here, so the diff result. So this would be addition. So adding a field. And addition requires a function. So we just use a lens over it to modify the field name itself with a function muct of source. Yeah, so I think you actually do get the original v0 record, say, as an argument. In the example, I'm just using const there, but you could do something like that and then just provide a little Haskell function for doing that kind of stuff. So you could do a little if logic and look at other fields to figure out what that should be, if that's what suits your program. So it's not like a ton of code to this library. It's just pretty dense if you haven't seen this kind of stuff before. Any hoozle, back to the adventure engine. Thanks for the diversion. It was fun. Yeah. Yes, const ignores the parameter and just returns whatever. Just the value, the constant. So you can call it with anything. And if I call f, I can call that f equal const foo, always foo. Now the type of f is some function b returning an a. All right, so it could take, it just ignores b, it always returns a, so I can call f on 1, 2, 3, f on always, it's always going to return food no matter what you do. There's only one answer. Always foo. Right, so in that example, then the type it's getting as a parameter is the old record. So if there's a way you can construct honorific, it's good for, like, if you had a record before where you had just like a name field as a string and you have some parser for names and you want to split out the names into different fields for whatever reasons, you could do that with that function because you get the old record with that field. You can run your parser on it, upgrade it to the new version, the new schema for that object, that record. So that's what I'm hoping will save this save file stuff. Because it was kind of useful for that project, for sure. Okay, let's see now. What do we do now? To do. Unused arguments warning, rename world log messages. There's some cleanup stuff. We can go right into that. A couple ideas for object interaction, actually. Item to item. It might be useful, and there's a lot of kind of puzzly type things where you want to, part of the puzzle is like finding some way of interacting with another item or another game object. Now the game object might represent, I don't know, say there's like a fire and there's a key in the fire. And so the description of that item would be like, there's something in the fire. And so you're like, how do I get it? Right? I can't just take from the fire, because it would give you, if you try to treat the fire as a container game object, right? And get in there, you wouldn't be able to get it. Presumably there'd be some kind of error message if you tried to use one of those verbs on it. And the idea would be that you would have to get, I don't know, a bucket, right? And you'd have to pour water, a bucket of water, and use the bucket of water on the fire. Now we're gonna have to model some way of making the bucket full or empty of water, and also applying that water to the fire and then changing the fire, the state of that game object, right? And so there's a couple ways we can do that with our framework. And what we have so far. Yes, like submerging a bucket in a pool would be the obvious thing to do, the kind of obvious thing you would do, right? Is anybody who's held a bucket before and knows what it's used for could figure that out. You pour water on fire, and then as a result, you get a key. All right, so now you can use you can get the key for doing that. We might want to model it so that just as a result of applying that, you just get the key right away, or now you can examine in the fire pit or whatever, and reach it out using some of the other container verbs that we already have in place. I think what we have right now is the ability for different items to carry verbs with them. And this might come in handy. Because this is the list. Of course, we can append things to the list. All right, we can remove things from the list. So when we dip the bucket in the water, we can append a pour verb to it. And then when we pour the bucket, when we use the pour verb, it can remove itself from the bucket. Right? It does the thing at once, and that's it. That's one way we could model that interaction with those things. And that's kind of where I'm thinking of that kind of thing right now. So yeah, it's kind of like in doing that, I'm not sure if we want to tackle parser 2.0 either. I think we'll be fine with the parser we have right now. Because all I would want to be able to write is, let me just fire up the game engine so you can see on the screen. I would want to be able to write like pour on fire. Or even, we could even just write pour fire, pour on fire. Right, we have a pour verb available to us now, like pouring, pour. And just like with the dig, with the shovel, right, now we have a dig verb. Right, because we're on, I don't know, we're in the front porch. Yeah, so we're digging next to the porch or something. We dig around the ground and we get something. Because this room has the ability to handle digging. So we get a weird coin for doing that. Similarly, I want to be able to have like item-to-item interactions. So this was with the room, an item to the room. Now, if I had a bucket, I want to be able to pour a bucket on a fire. So an item in the room's inventory, not in the room itself. Yeah, and if you don't have a bucket of water, you don't have the pour verb anyway, so you wouldn't be able to pour anything. And so the idea is that your verbs are built up by the things you are holding and the built-in verbs that you're just capable of doing if you're not holding anything, like walking around, looking at things and stuff like that. And so we can add capabilities to items by adding verbs to their maps, and those verbs can do other things, interact with other stuff. So let's try and model some of this out with some data structures first and add a bucket to our world and see what we can do, how far we can get with this idea. Just kind of play around with it. So I don't have any, do I have any outstanding changes? Yes, actually I got to commit this loads. So we add the load game command. Just load game command. I have previously saved file. Cool. So what are we using for rendering? We're using this really sick hot Haskell library. If you haven't heard about it, oh man, it is so cool. It is a wonderful library called Monomer. Monomer is written by this wonderful person, Francisco. Hopefully that's how you pronounce it. Valerino. It's a nice library. It's built, I believe it uses SDL2, OpenGL as a backend. It is a widget rendering library. Follows a similar architecture to Elm. So if you've ever built something with Elm before, it's very, very familiar to that. Haven't done a whole lot of that, but I understand the basic Elm architecture. I tried using Elm many, many years ago, and it was fairly pleasant. So it follows similar patterns to that. It's a pretty handy little library. So I've been learning a lot about how to use it on this stream, building up, and that's what we're using. And part of that's just because it's kind of cool. It's better than like a little text console UI, in my opinion. It allows us to be hopefully a little bit more cross-platform if this compiles well on Windows, which it's mostly pure Haskell, and I think the SDL2 library works on Windows as well, ? But the idea is that we could also add some nice features to our game engine eventually, which I want to be able to do like custom OpenGL, so we can add images and art and stuff. Yeah, you're welcome. All right, so we should be able to eventually add graphics to the game engine as well, so that we can add a little bit more visual interestingness to the game. And the only kind of drawback so far, and I don't know if this is being worked on yet or not, is just accessibility. So one of the wonderful things about text games is that if you are somebody who is impaired in their ability to see visually something rendered on a screen, there's a very rich language for us to use to describe what's being seen. That if you have a program like a screen reader or something, you might be able to use, but I don't know that Monomer like renders the text in a way that is usable to those kinds of programs. So that's kind of one thing I'm a little bit biting my lip on. I'm not sure how we can make that happen, but it's pretty early days in library, and I'm sure we could even make that a project on the stream, perhaps. So that's the only kind of like trade-off, I think, using a library like this, whereas maybe if we used something like Qt or something like that, there might be more built-in operating system support because it's using somewhat native widgets there for that sort of stuff. But I'm confident there would be a way to do it, at least. Because it is just, at the end of the day, there is just data in the engine. It doesn't really do anything more than just render stuff. So even if it came to it, we could write our own way to interact with a accessibility program like that. So it's something to look forward to, something to look into. Maybe we want to even put that in the to-do list, just to make it official. Nope, not file version. To-do, add screen reader support. Not sure how to do it, but it'll be in there. But the trade-off, the benefit you get though is that it is fairly open like that, and this kind of library lets you create your own custom widgets, your own graphical widgets very easily. Okay, so let's look at our kind of like hard-coded world data that we have right now that we use to play around with. Let's model a bucket and this fire with a key in it. So current room, where is it? There we go. Bucket, coin, so on and so forth. So if we implement it as an item, like the fire, Let's work on the fire. Right now, we don't have a whole lot we can do with this game object. Right, it has a single state. If you look closely, you can see something in the flames. Oh wait, that's the title first, sorry. I will call it a roaring fire. Right. And we'll give it a description that says, like, there's something in it. If you look closely, there is something. Some object in the flames. Yes. Okay, so if you look closely, there's some object in the flames. You might be able to reach it, maybe, somehow, if you could douse the flames. Right, but as it stands right now, the only properties we can give to this item is like a verb map, a weight and a value, I believe. If we look at item, yes, sorry, a size and a weight, so some volume and how heavy it is. And then verbs. So other kinds of game objects that we can have other than items are containers, I believe. Game object. Oh, you have objects. Yeah. Object, we have an item or a container. It's one of the two things. So how do we want to model the fire, right? If we model it as a container, that's fine enough. That means it can contain things, and we can use the container verbs that allow you to look inside the container, put things in it, get things out of it. So we can model it sort of like a container, like it's a fire pit. The only problem with this container is that it's currently closed because of the fire. And in fact, it's almost like a kind of lock in an abstract kind of way. All right, and there's some way of opening that lock by using some verb on it. And that'll change it to another state, where then those verbs will now be allowed to be applied. All right, so if we apply the water to the fire container, it'll unlock the lock, and you'll be able to get into it. So much as you try to use some kind of regular container verb on it, that while it's locked, you'll just get some kind of denied message. Will I eventually move the objects to a data store? I'm not sure what you mean, Swarm Collective. Potentially. It could, yeah. So one of the goals of this project is to... In fact, if you want to clarify what you mean by data store, that's fine too. I'm just going to ramble about that, about the game engine for a second while you do that, because my time's a little bit off sync. So anyways, game objects, storing them. Right now we kind of have that in the world, quote unquote, right? The world in the game engine is kind of the database for the game. It's got a database of rooms, it's got a database of objects, it's got a database of exits that map those things. It's got the state of the player, what room the player's in, a pointer to that room. It's got an inventory for the player, another database of objects. Some current verbs that the player currently has. And log messages, which I think is only used for a couple of things. Yes. It's used for a few things, but I think I don't know if I'm going to move that or not. But so the idea, you could abstract this out and store it in something else. So you say, I notice that there are some game objects defined in the code, as various stories might use different items. It might be advantageous to have the game objects loaded from external source. Yes. Yes, that's exactly the point. So ultimately, because this is just a map of entity IDs and game objects, we're going to write some authoring tools that are going to allow game authors, myself initially, but other people interested in using this game engine, to do that. And it can load it from a file. Maybe it'll be a SQL, like a SQLite database file. Maybe it'll just be like a JSON file to start. And then the game engine itself will just seek out that file at startup and start the game. Yeah, so the only reason why I'm hard coding them right now is just for testing and development. That's all. Eventually, these are going to get removed. So it's kind of just, yeah, just to test things out, test out my code, test out the interactions, test out the features, without having to write all of that stuff first. So this is kind of how I approach a lot of game development. Like if I'm developing a roguelike, for example, it's very tempting to start with like the world generation algorithm and all that stuff. But oftentimes I'll just start with a hard-coded, map that I just draw by hand, and I just get the player to move around and bump into the walls at first. And as soon as I can get the walls blocking them, then I start adding doors. And I make the doors work, and then I add traps, and then I add mobs, and I kind of just create this little fake little tiny world out of those things just to test that stuff out. Until it works, and then you could start removing those things and loading them dynamically by loading data in and stuff. Yeah, for now, hard-coded. So we're gonna look at maybe making this some kind of container and adding like a lock to containers. And so when you lock a container, you should not be able to use any of the verbs that you normally use with containers, like looking in it, opening it, reaching in and grabbing something out of it, right? All of those verbs should have like should get their error message, their deny message from the object you're trying to act on, right? So in response to trying to open the container, I should get back why I can't open this container and display that to the user, right? So if the container then needs to have those kinds of messages attached to it, if it has a lock, or the lock itself should have those things. And if there's a lock present, then so there's a few things I think in this design we have to look at. Let's look at modeling that lock first, though. If we do it generically, we might even be able to reuse it. We have an exit lock that does kind of a similar thing. Right, an exit lock needs the key items. Similarly, also has a fail text and a success text. All right, and so like in our game engine, this is modeled, like right in our pretend game world right now, this is modeled with needing the shovel to walk through the front door, which is locked without it. All right, that looks like this. So we're loading up a fresh game here. If we try to walk in the front door, you see we get this error text. You find it won't budge. Why not? Oh, okay. Well, I got to figure that out, I guess. I might look at the door. I'll look front door, maybe. It looks like it hasn't been opened in a long time. It's kind of like a clue to me. Maybe I need... Oh, there's a shovel here. Maybe I can use the shovel to pry it open. All right, so I pick up the shovel. And now I can walk in the front door. Try that again. And I can go in. You knock in the door with the shovel. Now we're in the main hall. And hopefully that's not too So authoring this stuff, we're going to have to leave clues to the user, obviously, of the game, so that they can do this stuff. But the idea is that you don't have to use the shovel on the door, although maybe users might try that. But right for now, the way the game engine works is we just have to have that item in our inventory in order to use the door. Maybe we'll change that in the future, but that's the way it works right now. And yeah, so you walk in the door now. You knock on the door with a shovel. You still have the shovel, and here we are. Similarly, we have like a examine. I think it's examine the Brawly bucket, or it's look in Brawly bucket. I can't. Maybe some Brawlies in it, right? Look in Brawly bucket. Yeah, so we have a look in Brawly bucket. Look inside the Brawly bucket. You see a Brawly. Ah, interesting. Thank you, Swarm Collective. Yeah. An input history or something like that to go along with the scene history that we have. I will add that to the to-do list. The reason, the idea of saving the scene history too with the save game file is that it lets you kind of scroll back through the game history so far that you've played through to see how it went and catch yourself back up again if it's been a while since you've played the game. Good idea. Or at least see the results of what they input. The game messages. Yeah, that's a good idea. Cool. Yeah, so it would state the scene, the action user attempted, and the result of the action. Yes, yes, I think that would be very, very cool. In fact, I'm going to just copy paste that right in here. Swarm Collective. There you go. You're in my to-do file, Swarm Collective. I'll even put little stars around your name so you're in bold. Yeah, I think that's a pretty good, that's a good suggestion. I think that should definitely go in at some point. Okay, so if I'm running this game and I look at the Brawly, I see inside the Brawly bucket, we see a Brawly, but if there's a lock on this container, I should not be able to see what's inside of it. I should get the error message, just like the exit locks. So, let's go back to the engine. So is the exit lock merely for exits, or can we have is it just a lock? And we could put locks on exits, we could put locks on containers. They kind of behave the same way. There's a fail text. Although a container lock might have different fail text for different cases. The only thing an exit lock has right now is that if you try to walk through that exit, you can't. But there's a couple of verbs that work on our container. There's look in and there's take out of, or take from. So we probably want a separate type for our lock. For now, at least, and this might be the easiest way of doing it. If there happens to be some overlap, there's a more generic way of representing locks, we could probably do that. But for now, let's just do it this way. So we'll put we'll call it a container lock. So there's our constructor. So container lock would have the container lock locked. The state of the lock, is it open or closed? That could be a bool. Ian. That might be fine as that. Container lock. Look in fail message. Container lock. Take from fail text. And we need a success message as well. Container unlock. Container lock success text. Cool. So we display the success text when some verb that's able to act on this lock changes this from false to true and opens the lock. And otherwise, those verbs that try to act on containers, looking and reaching in, so on and so forth, they can display the failed text there, that kind of thing. So I think that's pretty much all we might need there. We're going to need a generic instance now so we can serialize this. Probably want to move those back up to the exit lock. And add a couple here. Deriving the instance JSON to JSON for container lock. All right, so if the user really wanted to hack their save file, they could just go in, figure it out, and like unlock the lock and solve the puzzle just by flipping this to false or whatever they wanted to, or true, and be fine. Yeah, so I don't know if there's a common abstraction yet. So I'm going to be specific first, and kind of hope that once the abstraction becomes obvious, going from a specific type to a more generic type will be a fairly straightforward refactor, rather than trying to maintain a very generic type up front, whose rules I'm not very sure about yet. If that makes sense. It's kind of where I'm going with this. All right, unless I can state something about the abstraction very, very concretely. Yeah. So sometimes I do jump ahead and go right for the generic thing, but just because I know, like, I'm defining the abstraction itself and what properties it must have, and so any valid implementation of that thing will have those properties. But for this kind of stuff, where I'm working more with nouns than I am with relationships between things, I think it's easier to just go specific and then kind of abstract out or extract out anything, commonality between them if we need to. So like there's similar things. There's failure messages and there's success messages. There's some kind of state. In this case, with the exit lock, this is like a very specific thing, the key items. That's how that door works, is it looks for the intersection of the player inventory and the exit lock key items. Which might need some instruction to the user so that they know that's how locks on exits work in this game engine, but otherwise, yeah, that's how those work. Whereas this container lock, the state is just true or false, and we're relying on the verb to change that. Now, in the case of like fire and water, though, we're going to get very, very specific here because we're going to construct this we're going to pre-construct this scenario, right, with the water. And we're going to have some function with a verb like pour, right? It's going to look for particular things, right? It's got to look for particularly that I'm trying to pour onto a particular game object that is the fire object in order to make this work. So we might run into something with that there at that point. And what we might run into is kind of the one thing that I'm trying not to get too far into with this iteration of this game engine. Yeah, that might be a way to do it, is like have like entity IDs for yeah, like some kind of key combination that we can test against. That's a good point. Thank you, Swarm Collective. What I'm trying to avoid, I'm getting ahead of myself here because I overthink things sometimes, is building like a full-on like Inform 7 style or Inform style, Infocom style game engine where their game engine is designed around a programming language, the Inform language, which is a cool approach, something we could totally look into on this stream. But for this game engine, I just wanted it to be more concrete and just kind of a very limited experience with a data-driven style kind of game engine. If that makes sense. Like some amount of programmability, but nothing too wild. And then taking what we learned from this game engine and maybe folding that into, and was kind of the same idea with doing something concrete to something more abstract in a later iteration. So I think once we have container locks and maybe a couple more little puzzly type features, that'll be just enough to implement simple puzzles, escape room style puzzles, maybe even some kind of narrative that we could write a pretty neat game with that. And then move on to the next project. Once we get like a couple more things, because there's going to be the authoring tools. We're going to want to figure out how to make content for the game engine. Pretty straightforward to do, that kind of stuff. But yeah, that's actually good. Unlock verb, unlock item combo type thing. So basically, when the verb gathers some amount of data from the current state of the world, the player in the world, and if it can provide the list of things you need to unlock the lock, then it unlocks. Yes, I think that's pretty good as well. In fact, that even kind of brings us closer to the exit lock as well. It just has a few more error messages for different cases. Yep. Very smart idea, Swarm Collective. Yes, I like that. So then the idea is, yeah. Let's go with it. Okay, so let's just stick with that for now, and we'll do that kind of extraction at a later point. So we have a container lock. This is how it's defined. Actually, locked is locked a function of the container lock or a state of the container lock. Maybe we should make this still the Boolean. Keep the idea of the state. Key items. Almost exactly like, yeah. Ah, yes. Because then with the error messages, I think with the error messages, we could have like an error message map that maps the verbs to the error message to display. So if you try the verb on this lock, it displays the appropriate message. And so if there's multiple, the only difference between the container lock and the exit lock is that the exit only works with the walk verb, but container lock could work with multiple verbs. And so we could just have a map that maps those verbs to those error messages. Ah, Swarm Collective, yes! Okay. You know what I also need to do for this stream is I need to have rewards for good suggestions like that, so I can give something back for such a good idea. Ah, that's awesome. Okay, maybe I can do something here. I can make you a mod. Or an admin. There you go. All right, Swarm Collective, thank you very much. I'll think of a better reward. But for now, you're a mod. Okay, sick. I like this idea. In fact, I like it so much that I think I'm just going to go for that. Yes. Always a pleasure. Always a pleasure. Okay. Right, so let's just call it lock. Lock key items. All right, so in the case of like our fire example, we could have an entity ID for water available, right? And we can handle that situation of dipping the bucket and picking up the water with the bucket later, but yeah. And then presumably you'll have the water with you somehow in your inventory. And so the verb pour can look at the state of your inventory, notice that you have the water, remove the water from your inventory, pour it onto this thing, unlock the whole stuff. What's up, Android272? How you doing? Welcome to the channel. First time chatter, I see. Welcome. Be nice to Swarm. They've got good ideas. So the lock key items, the lock key error messages, error message map. Error messages could just be a map from verb to text. Pretty straightforward. And then the state of the lock. Sorry, it shouldn't be lock key. What am I doing? It should just be lock. Lock state. Bool. Or even better, just be lock state. It's exactly the same as Boolean. Right, it's only got two constructors. It's just more domain specific and interesting to the application. And just, you don't have to remember, does true mean locked? Or does false mean locked in this context? Just locked or unlocked is more straightforward. So generic and show, we'll do that. We're going to need JSON instances for those things. Just lock. And lock state, sorry. And put that to lock state there. Yeah, there you go. I don't know how many interactive fiction developer streamers there are out there, but if there are none, we're making history right now. Think about that. First, Android making an interactive fiction game with Swarm. Cool. Yeah, that's neat. What is Swarm? Is it an interactive fiction game engine? Will I find it with Google like this? Looks like there are some games called Swarm. Maybe if I put engine as a keyword. Okay. You're gonna have to link me that sometime. In fact, I'm gonna have to follow you, Android. Check it out. Cool. I wanna follow that and find out and see. So when your internet gets better and you're streaming again, I'll be there. Yeah, so I mean, in the meantime, this one is more of like in the realm of interactive fiction games. I guess this engine's more of a like, you could write narrative type stuff, but it's not like a parser heavy game. It would probably be more like an escape, like a puzzly type engine, I would imagine, is the kind of game we're going after here. Right, this is our thing. We're gonna add graphics to it and that kind of stuff, and accessibility. Ooh. We got a new follower too. Thanks, Android, for the follow. The best way to know. You made a good decision today. It's the best way to know when I'm streaming. I do these once a week on Tuesday nights, by the way. So what genre are we going for? Well, I'm still kind of doing world building for it, but I tend to like horror type creepy stuff. So it'll probably be something solitary, lonesome, and a little bit creepy. And mechanically, genre-wise, more like escape roomy puzzle type stuff. So figuring out what items you need and how to get the different things to unlock stuff and interact with things and hopefully have like a nice flow to the puzzle graph, if that makes sense to you. Yeah. So that's that. We got input handling here. We can pick up the shovel. Oh, this is all hard. This is just a hard-coded test area. It's not actually part of the game or anything like that right now. Right, you walk through the front door, and if you have the right items in your inventory, you can go through the exit and that kind of stuff. Then we have saved games and load games we just implemented tonight. And we're in the middle of doing locks. So we want to be able to add locks to things like containers. So this Brawly bucket here, for example, is a container. All right, we can examine it. It's a rusting iron bucket. There may be some Brawlies in it, which gives you the kind of the clue that you can look in Brawly bucket. And inside of it, we can see that there's a Brawly. Ah, yes. I've been tempted to pick up that board game. Have you played that one? Would you recommend it? Because it looks a lot like it looks pretty fun. I liked what they did with the branding and stuff on Choose Your Own Adventure, and I really hope they bring back more of those books. I'd also like to see the fighting fantasy books come back too. I don't know if you played those, the Steve Jackson fighting fantasy game books. Those were neat as well. I really like those. I'm thinking of maybe adding some elements of that to this game as well. 4 or 5, eh? Wow, okay. I might pick that up then. Thanks for the reco. Cool. So our special commands for like our meta commands are like quit, save, load, that kind of thing. Yeah, okay. So we have the lock state, locked or unlocked. We have a map of the lock key error messages so that if you try different verbs on the thing, it should respond with the appropriate text item. And then if the verb that we implement that kind of unlock a lock can then examine the state, the player state for various items in the inventory that they have in order to do this. Cool. So let's add the lock to our hard-coded fire. Let's make it not an item, but a container. Container has a size, I believe. The weight would be a calculation of all the things in it, technically, if we want to, like, you know, model that. I don't know. I put the weight in there thinking I might use it. I don't know if I actually will, but might want to remove that at some point. So it takes, let's make it empty for the moment. All right, so it takes a map of things that are in it. And we're going to need another parameter, whether it should be locked or not. So we'll put just fire lock here. And we're going to have to define what fire lock is, and we're also going to have to update the definition of our container. So container lock might be present or not. Maybe lock. We'll have to add that. Now, oh, we need some instances for our lock type. Yeah, I forgot to add a couple there. And our smart constructor for container. Here. Maybe lock. And container items and lock. I'll have to be a little less point free to make this code a little more clear. So container size, container items, and finally lock. And in order, if I want to have a lock smart constructor later, I'm just going to rename that to container lock. And that should be good. Okay. Now I'll just jump back down. Our definition, now we have to have a fire lock. Okay, cool. So let's just bring up the definition of lock so you can see it next to what I'm writing. There it is. Okay, so the key items that you need in order to unlock this fire lock, we're going to leave that empty for now. We need a map of empty. We'll leave that empty for now as well. For a second, anyway. And lock state. This is what I really want to test first. Locked. Okay. as always on the stream, I do everything in like really tiny steps. So for now, we do nothing there. Everything should compile again, hopefully. And what we want to do in our next step is put this fire in the world somewhere, actually, that we can interact with it. And we're going to try and look in it. Examine should still work, but we want to look in the container. Oh, examine, actually. We should probably put examine in the map, because we might want to change... Ooh, the state of what it looks like in the game world. Depending on whether it's locked or not. Interesting. Okay, we'll get to that in a second, though. But I want to be able to block at least that one verb when the state of the lock is locked. So let's make that happen first. Let's put the fire. I don't know. Let's put the fire in the front room. Let's just put it outside. Front door outside. Yeah. That's an exit. Where's the front? Porch. Front porch. Again, this is all just hard-coded right now. So eventually this will all be data-driven and be loaded from a kind of file of definitions. So we can put... These are the items in the room. We put the fire here. The fire container. We should probably also block pickup as well. We're going to have to give an entity ID to our fire. And it has to be unique, of course. And because we're hard-coding all this, we have to like hard-code all the IDs, but the game loading system would actually load all the IDs for us. So let's see, 8, 9, we're on 10 now, I guess. Front porch. Identity ID 10, and that'll be that. Okay, so we're added it there. And then we'll add the entity ID to the database of items in the world, game objects, fire. That should compile. And that's successful. Okay. So now if I load up the game engine, all right, we should be able to, we see a roaring fire, a purse, and a shovel. We can examine the roaring fire. We actually have to type in the full name, I think. I don't know if I've implemented aliases yet. I can't remember. Oh, it's just examine a roaring fire. Oh, did I do something weird here? I did do something weird here. Okay. I'll have to keep note of that. But anyways, so we get a roaring, we examine it, we get a roaring fire fed by some unknown source of fuel, blah, 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 which is our text description. Might have mistyped in it. But you see a roaring fire, blah, 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 blah. Okay. So what I want to have happen is that when I go to look in fire, we shouldn't see inside the fire, you see. We should get an error message or like some kind of blocked message because it's locked. Right? That's what we need to do. So, look in container is my function for that. part of handle look. So when we look in a container, we now should look at if the container has a lock or not first. That would be the simplest thing to do, right? So we have the container game object. If it's an item, then we have to throw an error, but if it's actually a container, then we get the container. This is where we should look for the lock. If it is locked, and if it's not locked, we should do something. All right, let's just do it the simple way. Like, let's just use an if statement. Or case match, pattern match, sorry, on the lock. So, container lock cont of nothing, there is none. This is the old behavior. There is no lock. That should all continue to work. Indent properly, please. Yeah. Okay, and we'll leave that undefined there for the just case where there is a lock. And this will just let us verify that the old behavior still works. And if we get to the looking in the roaring fire, we're gonna encounter undefined a runtime error. Lock the front door. And we're gonna look in the Brawley bucket. That should work just fine. And we'll walk through the door. And we're going to look in the fire. We still see inside the fire, you see. Oh, we ran in the game engine a little bit too soon before we did compiling, maybe? Look in fire. Yeah, there we go. That's what I expected to happen. Undefined. But if we pick up the shovel, we walk to the front door, and we look in the Brawley bucket, that should be fine. Okay, we see a Brawley. Cool. So we know that works. So we just have to implement it now. So basically, we want to examine, at least in the error case that we're trying to do right now, is we have the lock. Go to short name here. Now, we have to look in the error map for this verb to get the proper message, and we're going to return the world with the log messages from the error here. So that should be pretty straightforward. Looking into that is just m.lookup. Do we want to throw if it's not in there? It's probably some error. Probably, we'll just use my catch-all space wizard error for now and put a more appropriate one there when I can think of a better one, just to make the code work for what we're trying to do right now, what we're trying to focus on. And oh, we have the lock. No, first we have to check the lock state. We shouldn't just unconditionally return the lock message. So we could do that with a pattern guard. Lock state LCK is unlocked, or is locked. Otherwise, that would be the success case. I'll leave that undefined for now. Okay, so yes, let's see. Let's focus on this. Yeah, that should be an arrow. And that should be an arrow as well. Okay. What's our type error here? There just must be a last name. Okay, so maybe throw m.lookup. We take the key we're looking for, which should be a verb. We're going to use look. I'm not super happy about that, but that's fine. Verb look. And the map we're going to look into, which is going to be lock state lock. What am I doing? Lock key error mess. Fail messages of the lock. I think that was what I just can't. I don't know why. My brain's flying all over the place. There we go. Fail lock messages of lock is the map we want to look into. I think we'll probably get a type error if that's wrong. If that's not being overridden by this problem here. But if that's the lock message, error message that we get, is it still locked? Then we want to return pure W, the world, with world log messages. And concatenate on our message. Basically like that. Yeah, it's not the right thing. I probably meant lock key error messages. For some reason, that doesn't seem like a good name. That's probably more what we meant. Something that tripped Android up when he was putting locked doors in their game is the idea of literal locked doors versus figurative locked doors. Right. Yeah, so that hopefully we're implementing figuratively locked things. Our goal right now is to implement this idea of being able to there's like a key in a roaring fire. And we want to be able to get the key in the fire, but we can't do that just by reaching our hand because it'll burn, right? So the idea is that if you tried to reach into the fire to get the object out, you'd get an error message like, ouch, that hurts. You know, you can't do it yet. Unless you unlock the container, which is the roaring fire with the lock on it. And the idea there is that you have the appropriate things to unlock the lock. And when it's unlocked, then you can reach in and take the thing. So we need to change the description of the container, what's displayed to the user when the state is unlocked versus locked, and things like that. But we should be able to, like, instead of say this container is locked, we would say whatever the user programmed their game to display as a result of the failure case. So they would just be able to map those verbs, which we know we can serialize out. And then we can take text and map that back in. Hopefully that should all fit together. So I'm going for a figurative lock here, if that makes sense. But if I'm missing something about this, let me know. And then maybe you too can become a mod. Right, so if the verb is look, we know that here. I'm hard coding it in. That's fine. Key error messages. We still got to type error though. What's my error here? Oh, I got it. It's misspelled. Lock key error messages. Oh, MSGS. That's what it is. I saw that in the valid hole fits there. Thanks, GHC. Super helpful. As always. My buddy, the compiler. Okay, and then we have, let's see. Yes, a redundant do found. Okay, and a non-exhaustive pattern. Ouch. Save file error. I guess I should put that in. Cool. Okay. We're compiling again. So I don't have anything in there in that map right now. So if I do try to look in here, I should get the Space Wizard error. Yeah. That makes sense. So we're going to make it so that we can type poor canine, dump bucket, spit on fire. Yeah, so the way the engine's right now is set up, it's very, very simplistic. It's not very parser heavy. We just have the concept of verb something and how the verbs handle themselves are dispatched and kind of hard-coded. What's dynamic about it, though, is that the verbs that are available to the player is dynamic. And some items can also have one or more, or no, verbs associated with them as well. So when you pick up something into your inventory, it will add any verbs that the item has to your inventory list, your inventory of verbs, so to speak. And then when you drop an item, similarly, it'll remove that item's attached verbs from your inventory. So if you pick up the shovel, for example, the shovel has a dig verb associated to it. And if you remove the shovel, then it removes the dig verb. Yeah, Swamp Collector. I think whatever the user typed in and worked, or even if it failed, maybe. We should record what happened in the past, because it's like irrefutable. right? So I think that's what that should do for sure. But yeah, so that's the general idea. Is we kind of can mix and match these verbs. So in our scenario where we're trying to model this idea of the fire, this container that has a lock on it, the fire, this sort of metaphorical lock. When you use a verb on it that it'll be attached to the key item, that verb will be able to look at the player state to make sure that they have, like, say, water in their inventory, the right entity ID associated to this lock, to unlock it. And then we can change the state of the lock to unlocked and update other stuff. Like, for example, with water, we're going to have to remove, once we use the pour verb that comes with the water object, then we're going to have to remove the water from their inventory and model the water leaving the user from being able to use it. So they no longer can pour things. Same with the shovel. When you drop the shovel, you lose the ability to use the dig verb. Right? And the dig verb interacts kind of in a somewhat hard-coded way with the game engine, in that you can only dig things in the room, or you can dig in the room. And so when you define a room, you can define if it's diggable, like if it has something you can dig in there. You can define layers in a list of things you can dig up. So if you dig the first time, you'll get the thing at the top. And you're literally digging through the list of items. So our front porch has an example of that, where you can dig a coin buried in the front yard. But if you try to dig in and you can see that here, you get a little hot digging, but you find something, and then you get a new item to your inventory. But if you dig in the main hall, you just get, you can't, some error message that the author can define, like you can't do that here, for example, in this case. All right, so my idea is that we'd kind of mix and match these verbs and things you can do by moving them around in the world, and hopefully the interactions will. This design will keep everything all copacetti, but we'll see if we run into any issues with it. So far, so good, though. I think we'll be able to implement the fire puzzle with this idea. So we're getting Space Wizard right now because this map is empty. We can initialize it with something, list. Wrap that in some parentheses. And we have to put the verb look here and some text. Yeah, an autocomplete. Yeah, for sure. We could maybe add it to the UI itself, or autocomplete might be just the best way to do it, so we don't clutter up visually things. That would be easily implementable. Yeah. Verb autocomplete. Thanks for the tease. Swarm Collective, you're the best. That's 2 awesome ideas from you today on this stream. I even realize I misspelled your name on stream, so I'm going to fix that too. Swarm Collective. Android, your game started out as a text adventure, yeah. And you wanted to put in the game back. It's goggles, a fish shell terminal like text prediction. So when you start typing dig, D would be white, while IG would be gray. Ah, that would be nice. Yes. So we should be able to do that because we have the available verbs to the user in the game state as the keys to the map. So with a pretty straightforward lookup, we should be able to get just the beginning of the input buffer and filter out the list of keys to the ones that match. And then, yeah, do the special highlighting. That would be super, super slick. And as we think more about accessibility as well, so like I have a to-do item here to add screen reader support. So for Monomer, I'm not certain about this, but I'm pretty sure it doesn't have like screen reader support, so you wouldn't be able to like point Dragon Speak at it, and then Dragon Speak would be able to read the text on the screen to a user who uses that program. We might be able to add some support for it somehow that way. But it would also be great to have that for those users as well, to have a way to query what verbs are available. What can I do right now? Like, this is the world, this is what I'm seeing. You know, how can I interact with it? What's available? I don't want to just like say stuff and then see if guess if the game can handle it. And maybe I don't want to trudge through a manual and have everything written out for me, especially if I'm going to get new verbs by picking up items by playing the game. So yeah, we should probably think more about how to do that as well. So part of accessibility and screen reader support. For programs to read text from our game and query the game state. Verbs, available verbs, inventory, etc. Yeah, it certainly can continuously add more and more to it. I'm trying, what the heck's going on with Pretzel here? I just decided to update on me. Good times. Music's back. So, yeah, these are all good things to add. My goal for like the version 1 of this is just to add just enough puzzle type interactions between the items and the verbs, and using that a little more, to be able to have like graphical backgrounds for different scenes, and effects, and yeah, we have the inventory list and things like that. Make it look a little nicer, and then have the authoring tools there so that from there we can build out the game content itself, and maybe deploy an actual finished complete game as a standalone executable. Sweet, Android. That's awesome. Yeah, we could totally do something like that. So depending where you are in the game or whatever, we could have, it's just an SDL2 context under the hood. We have access to the OpenGL context through Monomer. So that's the idea, is that we could have different backgrounds available to it. Or like we can have different, I don't know exactly how to do it yet, represent it yet, but I kind of want to add some graphical, changes to the thing as you play the game. So give it a little more atmosphere for visual people who can see the rendered game. That would be kind of cool. I don't want to get too carried away with it, but I would really, one thing I'm toying with, if it's not going to be too difficult, would be to integrate some kind of conversation-based system. I'm kind of going for more of a solitary type adventure, but I think it would be neat to have like a rudimentary conversation system with branching conversations with NPCs as part of the puzzles. Yeah, so, but I might slag that and just leave that out for this version just to keep the scope kind of small and not get too carried away. But definitely graphical backgrounds are definitely going to be there, so I don't think that'll be too hard to do. And yeah, branching NPC conversations would be a little bit harder. I'd probably reach for something like Inkle, I think it's called. Or they have a tool. Yeah, Inkle Writer, I think. Maybe this is what I was thinking of, but I was thinking more about maybe it is Inkle, I don't know. But there was a tool somebody wrote to handle branching conversations. To do it. Anyways, if there is some kind of tool to handle like those kinds of branching NPC conversations, that would be great, and I'd probably just use that. Otherwise, I might just scrap it and do that for a later project. Yeah, that's starting to look a little bit more like a full-on engine of its own. Which, if you haven't played any of their games, they're amazing. Yeah, this is looking more like an engine kind of thing. There was one they did. I could have sworn it was from Ingle because it was from the developers that did one of their games. Well, they did Heaven's Vault. Yeah, maybe it's like this. Maybe it's Ink I'm thinking of. Or like I'd have to write my own to integrate with a future version or something. But yeah, the idea is that the NPC state would be like one kind of like self-contained story in this kind of language, so that you can author it in this language, and then you can interact with some NPCs. That would be kind of neat, but I don't want to increase the scope of it too much. But we'll see. If I'm having a ton of fun with it, why not? You know, it could be a lot of fun. But that would add a significant amount of scope, especially with the whole saved state kind of thing as well. Yeah, Twine is another cool engine. I really like that one. So if you're watching, Twine's an open source tool, similar to what we're building, but in a very different way, where you can kind of build these interactive stories as like a graph of different nodes, and can navigate through them using Twine. We might end up building something similar for the authoring tools on the back end, some kind of UI for a thing like this, where you can have the room objects and then the exits between them, and be able to do that all graphically. And then it would output a file that you could run with the game engine, or we could write a compiler that would package the two up into a single runtime executable that would just load up the game engine, fire up the data file, and go to town. cool. Yeah. So, I mean, the focus here isn't necessarily, like, I am building the game engine for funsies, but it's also just to show Haskell and stuff like that, too. So we're building a lot of this from scratch, just for the experience of learning something. So it gives us kind of a practical project to get into, to learn Haskell. Other projects I've done on the stream have been like building database libraries and things like that as well. But this has been a really fun one. Okay, great diversion. Let's see here. Where were we? We were just about to add our error message, I believe, to the fire lock. So we added the verb look. It hurts your eyes to look in there. Only to put the flames locked. Okay, so now we shouldn't get the space wizard error message anymore, I don't think. If we look in the roaring fire, yes, we get it hurts your eyes to get too close, but there's something dark in there. If only you could put something. So the other thing I'm noticing is we're not getting really text wrapping on those messages. So if something's wrong with my rendering for those, it might be that because I'm not putting them in the right place with regards to where Manover is doing the wrapping and the rendering, so I should probably fix that. But we are getting that working, so that's good. Pardon me. So that's great. Let's update this. Let's see. What can we commit this? To leave any debug code in there? No, it looks good. Okay, we haven't figured out how to handle the unlock case yet. That's okay. There's no way to unlock that lock yet, so we can leave it undefined for now, and everything should be fine. That's all good. Yeah, let's commit that. When applied, this change will add a... Actually, we should probably remove container lock that type. Yeah, let's abort. We don't need container lock anymore. Just lock. And one of our next goals should also be to remove the exit lock and replace that with this as well. Yeah, horizontal scroll bar appears. Yeah, I want to avoid that if possible. Text wrapping should be used appropriately. And Manover does have support for text wrapping, like it does do that. I'm just not rendering those messages in an appropriate node where that would fit and do the wrapping. That's a pretty easy fix, I think. So, let's see. Yeah, we need to get rid of the container lock. That's good. That's committable. So when applied, this change will add a lock type and an example container with a lock. Oh, I want to reword that. What did I do? On stage changes. Oh. Yes. Okay, let's rebase that. We're going to squash that down. We're going to reword that one. Also changed the look, the handle look in handler to look at the lock state if it exists. That's good. Okay. That's fine. Yes. Good. And next thing. is we're running low on time, friends, this week. So let's update our to-do file before we go and push these changes up. So let's see here. That's good. We should add an item for this. Locks. There's going to be a few things we got to do here. First is we're going to have to remember next week to handle unlock state in handle lookin. And that'll complete that story. We also need to replace the exit locks with locks. And yeah, finish the fire story, maybe. Oh, we need to be able to unlock a lock. Right, when you have the right items. Which currently is done with, at least with the exit, when we do the exits. The exit lock is handled just by having the right items in your inventory when you go to use the verb, which is fine. You might want to just preserve that behavior when we go to the locks, but I think we should be able to do that. No problem. And that's pretty good so far. Yeah, that's enough. Cool, let's push all this code up. There you go. So if you're interested in following along with the code and checking it out, it's available here at Agent Ultra. That's me. That's not me. /adventure-engine. They're on GitHub. So give it a star. Give it a fork if you'd like. Try it out. See what you can do with it if you're interested in trying and learning some Haskell and following along. Or you have your own ideas and you want to implement them. You can also go to this cool declarative.tv website. The link's above here. And meet other cool streamers who do functional programming such as me. You can get a link to our Discord and join us there. If you're streaming yourself, you can get listed on our special, cool, awesome site and learn more functional programming and hang out with cool functional programming people. This has been another week on the agency, and I'm Agent Ultra. May your monads always be free. May your types always check. Thanks for hanging out. It's good to see you. And I'll see you next week. Bye for now.